Welcome dear students. Today in this video I am going to explain about one experiment. Our experiment is, our aim is to study the lateral displacement of a ray due to the refraction of light through glass slab for different angles of incidence. For this experiment we need some apparatus. What are the apparatus required? For this we need a glass slab through which we will see the refraction of light, a white sheet, paper pins, some other pins, scale, protector, pencil, etc. As we know, refraction is the phenomenon of light in which when a ray of light travels from one medium to other medium, it deviates from its original path. So let us start our experiment. For that we will take a white sheet and with the help of some paper pins we will fix it on a soft board. So as I am doing, first we will fix a white sheet on a soft board. After then we will keep the glass slab on it approximately in the center and we will draw its outline like this. After then we will remove this glass slab and using our protector, first we will take a point. Suppose a point we have taken and this point we have taken as O, and from this point we will draw a perpendicular using our protector. One perpendicular we will take, and angle, certain angle we will take, that is, suppose I have taken an angle of 30 degree. Then after we will complete this is the normal which I have taken, and this I made an angle of 30 degree. We will produce it by a dotted line through this glass. After then we will use some pins, this type of pins we will take, two pins we will take, and first we will mark 2 points on this. Let this point is point P1 and another point is pin P2. So 2 points we will write here, first pin 1 and second pin 2. We will just press 2 points in this soft board and that should be straight. We will try to keep it straight. Next one, the next pin we will press it at certain distance. We will try to keep a distance of around 2 to 3 or 4 centimeter. Then after we will replace our glass slab on this outline. Once again we will place it on its outline. Be careful that it should be fixed as it was earlier. So after fixing this we will take 2 more pins in our hand and we will just see what we have to do now. Then next we will set our eye along with this glass slab. Let us check now. And from this side, after setting, we will take one pin in our hand and keeping the other pins from this side, from this face of the glass slab, we will see that 2 pins. And along this path we will fix it as that pin should not be visible. That means we will press this pin in such a way that the other 2 pins are not shown in a straight line, and another pin we will fix so that we are not able to see all these 3 pins. Students, we should use our one eyes, otherwise there will be an error known as parallax error. So the 4th pin we will fix now in such a way that we are not able to see all these 3 pins using this. After this, children, after setting this arrangement, what we will do, we will remove this glass slab and using our pencil and scale, we will first mark here pin 3 and pin 4 and then we will join that line, and after then we will draw the perpendicular to that. So let us just see what I did. Okay, so we will just I am just did this, and now you can see I will remove this, all these pins I will remove. So you can just see we got this line, and in this what we are finding, this is incident ray, this is refracted ray, this is emergent ray. So, and this angle is known as angle of incidence I, this angle is known as angle of refraction R. As this is the normal and this one is also the normal, so these two angles will become equal, that will be also R, and this angle is also becomes E. Now children, we are finding this incident ray, the direction of incident ray and emergent ray becomes parallel, they becomes parallel, and the distance between these two lines, this distance is known as D or called as a lateral shift. So this distance is known as the lateral shift. Similarly, children, we will take here the different angle of incidence. As I have taken this 30 degree, so using it we will change this angle. Similarly, we will change it for 40 degree, then for 60 degree. So more angles we will take and we will draw the same. And after then we will check this lateral displacement. So what we find, we will find that as the angle of incidence will increase, the lateral shift will also increase. So this is the calculation and this is the result of this experiment. Angle of incidence, lateral shift increases with increase in angle of incidence. So this is our first experiment, that is lateral displacement. So what is lateral displacement? Once again I am defining. Lateral displacement is the perpendicular distance from the direction of incident ray and the emergent ray. It is also known as lateral shift. We used to denote it with small d. So this is all about first experiment. Thank you students. Thank you for watching.